Okay, this is going to be a short instructional video on how to solve absolute value inequalities using the test point method. So we're going to be looking at absolute value inequalities like this, or maybe one like that. How do we solve these and graph them on the number line? First, we're going to do an example with no absolute value, right? And if you want, you can pause the video and then hit play when you get the answer. Try this on your own. But if not, solving this using the test point method, the first step is to find something called the boundary point, which I'll explain in a sec. So you find the boundary point, and the way you do that is you change the inequality to an equal sign. Once you do that, you solve for x like a normal equation. Add 2 to each side, gets you 2x equals 12, and then divide both sides by 2, and x equals 6. Alright, so picturing ourselves ahead of time, eventually we're going to get to the number line. So I'm going to draw one in now. Alright, and what we need to do is, since we found that 6 is the boundary point, we need to put a dot at 6. Now, because of this sign, less than or equal to, that is an indication that we should use a closed dot. Alright, so we could be 6 or we could be equal to 6. And now the question is, do we shade towards the left or do we shade towards the right? So the way you do this is you pick a test point. And what's the easiest test point? Use x equals 0. Alright, so let's start with our original inequality, and let's plug in x equals 0. 2 times 0 minus 2 less than or equal to 10. Simplifying, 2 times 0 is just 0. So we have 0 minus 2, and 0 subtract 2 is negative 2. Alright, we're left with these two numbers, this is a true statement. This is true because negative 2 is less than 10. So what does that tell us? Well, we used x equals 0, so that tells us 0 is a solution. Because when we plugged it in, it made the inequality true. So 0 is a solution. Alright, and that is the hint, the giveaway. Once you test a point, you know that from our boundary point, all the solutions have to be this way, right? Because if 0 was a solution, and one side of the boundary point will be solutions, then this has to be the side. The side was 0. Okay, so this has been a short review. Don't forget to write your answer. X is less than or equal to 6. Alright. So we're going to use the same idea to solve number 1 on your worksheets. Absolute value of p divided by 4 is greater than or equal to 3. Now it's tempting to multiply by 4 right away, but don't. This doesn't always work, so don't cross multiply yet. The first thing to do is find your boundary point. And the steps are the same. So finding that boundary point, the steps are the same. We take the inequality, but we change this inequality to an equal sign. And we make an equation. Alright, and here's where it gets different. I said find boundary points, but I should say find boundary points. Absolute value equations, in general, will have 2 solutions. Alright, so solving this absolute value equation, we have our equation without the absolute value sign equal to 3. And because of the possibility of a negative, just as we learned solving these equations, you have to make another equation and set it equal to negative 3. Basically, if I put a 3 or a negative 3 in here, it's going to output a 3 after absolute value. Alright, so solving to get the boundary points, we multiply by 4 on each side. P is equal to 12. And we multiply by 4 on each side. And P is equal to negative 12. So we have 2 boundary points. Alright, so let's think ahead to our number line. Alright, we have 0, and then some numbers, and then 12. And if we go to the negatives, we'll get to negative 12. So since we have a greater than or equal to, we need to use a close dot, meaning 12 is a solution, and so is negative 12. All right, so now what we need to do is, if you notice, there's actually 3 regions. We have region number 1, region number 2, and region number 3. So this is also where it's different. We're going to pick test points, 1 from each region. So looking down at region number 1, we need to pick a number over here. On the other side of negative 12, I'm going to pick x equals, I want something that will divide evenly into 4. So just being strategic, I'm going to pick negative 16. All right, now from region number 2, I'm going to pick 0. 0 is always a good choice. And from region number 3, I'll pick positive 16 for the same reason as before. I'll be able to divide that evenly by 4. Okay, so let me erase these just for neatness. And let's test these points in the original inequality. Okay, negative 16, if I plug that in for p, sorry, I said x, these should all be p. Negative 16 over 4, greater than or equal to 3, and we have the absolute value sign. Okay, negative 16 divided by 4 is negative 4, greater than or equal to 3, which seems false, but absolute value, right? So take the absolute value and out comes 4, positive 4, greater than or equal to 3, and that's true. So what does that tell us about negative 16? Negative 16 is a solution. And it doesn't matter which point I pick in this region, it'll always make that inequality true. If you don't believe me, you can test it, prove it to yourself. This is one solution region, and I do have to stop at the boundary points. I don't know anything about this region yet, and not until I test a point from this region, like 0. So let's plug in 0 for p. All right, now 0 divided by 4 is 0, so we have the absolute value of 0 is greater than or equal to 3. Now it doesn't look good. Absolute value of 0 is still 0, and in fact 0 is not greater than or equal to 3, and that's false. So 0 is not a solution. So what does that mean? That means there's not going to be any solutions in region number 2. Let's leave this blank. All right, and now let's test p equals 16. It's basically the same math right here. So here's the speedy version. Plug in 16. Divide by 4. Absolute value of 4 is regular 4. And just as with the other one, this is a true statement. So the number I plugged in, 16, is a solution. And what does that tell me? That tells me all the numbers in this region, region number 3, these are going to be solutions. 16 was our test point for that region. So this is my graph. And now I need to actually describe this. So I can see that numbers less than or equal to negative 12 are solutions. So p is less than or equal to negative 12. Or, and I need to use the word or here, don't say and. P is greater than or equal to 12, right? It's all the numbers greater than or equal to 12. So we need a graph, we need our solution, and we're done. Point, you might want to pause the video, try this one on your own, and then press play when you're ready to see the answer. Solving this one just like before, using the test point method, we first need to find our boundary points. As we noticed in the last example, there will be 2 because of the absolute value sign. So the steps in doing that are rewrite your absolute value inequality, changing the inequality itself to an equal sign. Once we're there, we follow our normal procedure for solving absolute value equations. You get rid of the absolute value to make one equation, and then you get rid of the absolute value again, but this time put a negative on the number side. So k minus 1 equals 4, or k minus 1 equals negative 4. Adding 1 to each side, I get 5, or negative 3. Thinking ahead, let's look at our number line. We have 0 in the middle. Here's negative 3. And here's 5. 1, 2, 3. Yeah. Okay, so we have a boundary point at 5, and it's going to be filled in, right? When we have a less than or equal to, we use a closed dot. We also have a boundary point at negative 3. Again, we need to test our 3 regions. Region number 1, region number 2, and number 3. All right? So we're going to pick a test point from each region and see what happens. Okay, from region number 1, I'm going to pick negative 4. Just going to pick the next point over from negative 3. That's in this region. Okay, I need to pick any point from region 2, which 0 is always a good choice because it makes the math easier. And then I need to pick any point from region number 3. So I'm going to pick 6. X equals 6 is the next point over into the region. That is a whole number. All right, now plugging this into the original inequality. All right, we have 0 minus 1. Oops, we're using negative 4 for k. And again, I said x, but these are the letter k. So negative 4 minus 1 less than or equal to 4. Negative 4 subtract 1 is actually negative 5. So the absolute value of negative 5 less than or equal to 4. And then the absolute value of a negative number comes out positive. 5 is less than 4. That's false. Right away, that's false. It's not less than or equal to 4. So negative 4 is not a solution. All right, so we can rule out region number 1. No solutions over here. Now let's test region number 2. Let's test 0. Okay, and plugging in 0, we'll do that in red. 0 minus 1 less than or equal to 4, using the same original inequality. 0 minus 1 is negative 1, and the absolute value of a negative number comes out positive. Now this is actually true. Negative 1 becomes 1 after absolute value. 1 is less than 4, so 0 is a solution. And what that means for us is this region contains solutions. I could pick any point in here, test it, and it makes the inequality true. Let's try one more, 6. We still need to test region 3. Region 3, plugging in 6. I have 6 minus 1, which is 5. And if I take the absolute value of 5, it's normal 5. Positive 5, less than or equal to 4. And that's false. So we don't shade this region because 6, the number we plugged in, 6, is not a solution. We tested our 3 regions, we have our graph, and now we need to describe this graph. So you have 2 options here. You notice that x is less than or equal to 5, but it's also greater than or equal to negative 3. All right, and traditionally, we don't use the word but. We use or for the other one, so we're going to use and for this one. So that's one option. Most of the time, however, you're going to see it written like this. You're going to see it written as x is less than or equal to 5, and x is greater than or equal to negative 3. Now, a lot of students mix up their notation on this. The most common mistake I'll see is something like that, which is wrong. All right? Now, why is that wrong? Well, if you're curious, if you want to stop the video, here's the answer. But if you're curious why this is wrong, check this out. We have x is less than or equal to 5, and we have x is greater than or equal to negative 3. Now we have a rule in inequalities where if I switch x and 2, if I flip the sides of the inequality like this, then the inequality flips with it, right? So if I flip x and negative 3, the inequality should flip with it. So if I put negative 3 on the left and x on the right, it still has to point towards x. The open mouth should be towards x. Now if you kind of sandwich and squish these together, if you squish the x's down, that's x less than or equal to 5, greater than or equal to -3. So that's the reason why we write the signs the way we do.